This is Saxon Algebra 2, homework help with lessons 54 and 55. Lesson 54 on page 236, problem 1. Sarah wants to mix 400 liters of a solution that is iodine 57.5. And she has two solutions available. So what is she going to mix? She's going to mix iodine 20 with iodine 70 to yield 400 liters of iodine 57.5. So we always have these two equations. This is how much iodine 20 we have plus how much iodine 70 equals how much iodine 57.5 we want. We know we want 400 liters. All right, so solving for iodine 20, we subtract iodine 70 from both sides, so that's 400, and that represents how much iodine 57.5 we have, minus how much iodine 70. All right, so we always do that with the first equation. All right, that's the first equation. The second equation is like the first equation, but we take the concentrate and multiply it by how much of that substance we have. So it's 20% times how much iodine 20 I have, plus 70% times how much iodine 70 I have, equals 0.575 times how much iodine 57.5 I have. I know I have 400 of this, so it's 0.575 times 400. For iodine 20, I'm going to substitute this in for iodine 20. So it'll be 0.20 times 400 minus iodine 70 plus 0.70 times iodine 70. 0.2 times 400 is 80. So I'm just distributing this 20% inside the parentheses, minus 0.20 iodine 70 plus 0.70 iodine 70 equals, we'll multiply the 0.575 times the 400, and we get 230. All right, you subtract your 80. Now you're just solving simple algebra, combining your like terms on the left, moving your constant to the right through subtraction. So 0.7 minus 0.2 gives me 0.50 iodine 70, and 230 minus 80 gives me 150. When we divide 150 by 0.5, 150 divided by 0.5 is 300. So I have in iodine 70, I have 300 liters. So back up to this original. It's iodine 70. I have 300 liters. I want a total of 400. So iodine 20, we have 100 liters. All right, problem 18. On that same lesson 54, problem 18 says find the equation of the line. So I want to find 2 points. Actually, I'm going to go to the very ends of it. So that point is 6, 0. So I know I have 6, 0. And down at the very opposite end is 2, -6. 2, -6. I just always go to the very ends, all right? I need the slope, and then I can get the equation. The slope is the change in y over the change in x. So here's my slope. It's -6 minus 0 over 2 minus 6. -6 minus 0, 2 minus 6. So that's -6 over -4, which is positive 3/2. Does that look like a positive slope? Yes, it rises from left to right. I have a slope, I have a point, I use the point slope formula. What's the point slope formula? Y minus y sub 1 equals the slope times x minus x sub 1. That's the slope point formula. Here's where I substitute in the points, the xy coordinate point, and here's where I substitute in the slope. So y minus the y coordinate z equals the slope 3/2 times x minus the x coordinate 6. Well, y minus 0 is just y. I distribute the 3/2, and that's 3/2 x minus 18/2, which is really 9. So here's my equation. Y equals 3/2 x minus 9. That is the equation of that line. All right, problem 19. We have an equal sign with an equation, so I'm eliminating the denominator. Always when we have an equal sign, eliminate the denominator. All right, so we have 4x minus 2 over 5 minus x minus 3 over 2 equals 7. We eliminate the denominator by multiplying by what would be the common denominator, and it's 10. 5 goes into 10 and 2 goes into 10. It's the smallest number that both of your denominators go into. So multiply every term by 10. I'm going to put the 10 over here because that's going to be a negative 10. So when I simplify and distribute, that will be a negative because of this minus sign, multiplying by 10. Before I multiply, I simplify. All right, I distribute the 2, so that's 8x minus 4. Now that's a negative 5 because of the minus sign. So I'm distributing the minus sign and the 5 at the same time. So that's negative 5x plus 15, because that's a negative times a negative, equals 70. 15 minus 4 is 11. So I'm going to subtract 11 on both sides. Combine my like terms on the left, so that's 3x equals 70 minus 11 is 59, right? 70 minus 11, it is 59. Divide by 3 on both sides. Let's see if that's a nice even number. And it is not. X is 59 thirds. All right. Lesson 55. Number 1. So I'm on page 239 now. Find 3 consecutive integers. All right, 3 consecutive integers. What are they? They're n plus 1, n plus 2. That's the first one, the second one, and the third one. Such that the product means multiply, product of the first and the second. So n times n plus 1 is equal to the product of negative 6 and the third. That's the third. Product is multiply. All right, we'll distribute the n, and we'll distribute that negative 6. So we have n squared plus n equals negative 6n minus 12. I have an n squared. I know I'm going to have to factor. I'm going to set it equal to 0. So I'm going to add 6n on both sides. And I'll add 12. And it equals 0. So we have n squared. These are like terms. Plus 7n plus 12. So I'm looking for factors of 12 such that I add them. And they equal 7. And that's 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So it's n plus 3 times n plus 4 equals 0. And then we ask ourselves, what makes this binomial equal to 0? Well, n would equal negative 3 to make this 0. And 0 times anything is 0. What would make this binomial equal to 0? Negative 4. When n is negative 4, this term is 0. 0 times anything is 0. But it wants the consecutive numbers. So it's negative 3, negative 2, negative 1. That's one set. Remember, when you have something like this, you're going to have 2 sets. For this one, the 3 consecutive numbers are negative 4, negative 3, negative 2. All right? problem 1. Problem 3 from lesson 55. One solution was bromide 5%. The other was bromide 40%. How much of each shall we use so we get 60 milliliters of a solution that is bromide 12%? So you always have that 1, and then you always have where you multiply the percent, right? You have to move the decimal 2 to the left to convert that percent to a decimal, times bromide 5 plus 0.40 times how much bromide 40 we have, plus 0.12 times how much bromide 12 we end up wanting. We always take this first equation, solve for one of the variables, and then substitute. All right, so we'll subtract the bromide 40 on both sides, so we end up with bromide 5 equals 60 milliliters minus how much bromide 40 we have. This is what we shall substitute in for bromide 5. We know how much bromide 12 we want. We want 60 liters. We'll substitute that in. You end up with one variable, which makes this equation solvable. All right, so 0.05 times 60 minus B40 plus 0.40 B40 equals 0.12 times 60. We'll distribute the 0.05, and that's 3 minus 0.05 B40 plus 0.40 B40 equals 0.12 times 60. Okay, I'm going to clear that out. 0.12 times 60. It looks like it's a decimal, and I will use the decimal. It's 7.2. We'll subtract 3 to move our constants to the right, combine our like terms on the left, and then solve for B40. So this is going to be 4.2 on the right. 0.4 minus 0.05 is positive 0.35 B40. When you divide by 0.35 on both sides, you get 12. B40 is 12 milliliters. If B40 is 12 milliliters, how much more do we need to get to 60? 48 milliliters of B5. All right, next problem is 21. So turn the page. All right. 21 on the next page is square root of 16 square root of 2. We don't have a common base. If we can, we want to. Can I put 16 equals 2 to some power? Yes, 2 to the 4th power is 16. So 16 is the same thing as 2 to the 4th power. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So where 16 is, I'm going to substitute 2 to the 4th power. And so this is 2 to the 4th. This is the square root of 2, which is 2 to the 1/2. All right, this whole term under the radical is raised to the 1/2. So it's 2 to the 4th times 2 to the 1/2. All raised to the 1/2. A power raised to a power, we multiply. The first term is 2 to the 4/2, which is just 2 squared. The second term is 2 to the 1/2. We multiply 1/2 times 1/2. That's 1/4. Common bases, we add, when they're multiplied, we add their exponents. So that's 2 to the 2 plus 1/4. We need a common denominator. So we multiply that 2 by 4 over 4. We add the 1/4. That's 8/4 plus 1/4 is 2 to the 9/4. You want a common base. Number 22 is much like it. and you want a common base. So it's the fourth root of 27. The fourth root of 27 times the cube root of 3. Yeah, times the cube root of 3. Can 27, is 27 equal to 3 to some power? And it is. 3 cubed equals 27. All right, I'm getting rid of some markers here. They're slowly being thrown away. All right, so for 27 under here, I'm going to put 3 cubed. For the cube root of 3, that's 3 to the 1/3. So all of this is the fourth root. For 27, it's 3 cubed. For the cube root of 3, it's 3 to the 1/3. This whole term under the radical is raised to the 1/4. So we'll take 3 cubed times 3 to the 1/3, all raised to the 1/4. It's a funny looking 1/4, isn't it? But it's 1/4. All right. Power raised to a power, we multiply. So the first term is 3 to the 3/4. The second term is 3 to the 1/12. When we have common terms multiplied, we add their exponents. So it's 3 to the 3/4 plus 1/12. But to add 3/4 and 1/12, we need a common denominator. So multiply this first term by 3 over 3. Because remember, we don't change a value when we just multiply it by 1. That's 9/12 plus 1/12, which is 3 to the 10/12. But I would always simplify it. Both of those are divisible by 2, so it's to the 5/6. That is your final answer. All right, number 25 is radicals, adding radicals. All right, so 25 is 4 square root of 2 over square root of 11. I'm going ahead and separating that fraction, putting each term under the radical. The numerator under the radical, the denominator under the radical. This is 2 square root of 11 over square root of 2 minus 4 square root of 198. All right, I'm going to look at 198 and see if I can simplify 198. All right, 198. I'm just going to see if 36 goes into 198. It doesn't. I'm thinking of perfect squares. So 36 doesn't. I know 25 doesn't. I wonder if 16 goes into it. It doesn't. Does 4 go into it? No. Does 9 go into it? Yes. So it's 9 times 22, and this is 2 times 11. So really, this is minus 4 square root of 9 times 22. I can unsquare that 9. All right? And what do I do to these? I multiply. I rationalize that denominator by multiplying by the denominator over itself. And this first term you multiply outside and you multiply under the radical. The denominator, any radical times itself, is just that number that's under the radical. This is 2 square root of 22 times 2. I'm going to pull that 9 out. It'll be a 3. Square root of 9 is 3. 3 times 4 is 12. Square root of 22. All right, I'll go ahead and write these. Now I want a common denominator. It's going to be 22. This first one, I multiply by 2 over 2. Second one, to get to 22 in that denominator, 11 over 11. This last one has to be 22 over 22. This first term is 8 square root of 22 over 22. This is 2 times 11, 22 square root of 22 over 22. All right, 12 times 22 is minus 264 square root of 22 over 22. Now I have like terms, so I just do 8 plus 22 minus 264. So 8 plus 22 minus 264 is a negative 234 square root of 22 over 22. Then I ask myself, can I simplify this? And I can. They're both divisible by 2. All right, so 234 divided by 2 is 117. So that's negative 117 square root of 22. I divide 22 by 2, and that's 11. I don't think, yep, that's not, this cannot be simplified any more than it is. All right, last problem, number 26. Estimate. We're not going to estimate. We're actually going to work it, and you can just put this one in your calculator. We're not going to do any estimating, all right?